Chapter 3, we're going to have a bunch of properties that we're going to memorize over the course of the chapter. So today you're going to be wanting to fill in from 1 to 13 on this paper from 3-1. 3-2 will add nothing to the paper. 3-3 will add a section or two. 3-4 will add a section. 3-5 will add a section. By the time we get to the test, there will be like a memorization sheet of 35 that we'll want. Tomorrow, what I'll ask you to do for 16 points is to duplicate what we're about to do on the board here, here, and there. So we'll just sort of dive in and do it. Tomorrow, the quiz, I'd give you basically a blank sheet of paper. So you get a point for the heading, and then you get points for filling in these properties. So we've got 3 headings that we're worried about today, and a bunch of properties. So the first category is called reciprocal properties. So what's reciprocal mean from your 7th grade sort of old math life? What's reciprocal about?
It's like
flipping stuff. Okay, what trig words have had something to do with stuff getting flipped? Trig words and flipping. Who connects to who?
Maybe like cotan and like cosecant. That kind of stuff?
Yeah, that kind of stuff. Who is their partner stuff? So who's like cotan's partner?
Okay.
Tan. Okay, so one reciprocal property would be that cotan is 1 over tan. So there's one. What's another trig word that's involved flipping to this point of our life?
Cosecant.
Cosecant. Cosecant is caused by flipping sine. Who else is in that club? Secant is from flipping cosine. Those could be expressed another way. Instead of teasing it out of you, I'll just tell you that sine times cosecant makes 1. Cosine times who would make 1 then? Sine. No. Sine. I did the wrong thing. It should be sine times cosecant. That threw us off. Sine times cosecant makes 1. Sorry about that. Cosine times who? Secant. I'd agree. Who's the missing duo then? Cotan times tan. If you multiplied those in a different order, would it hurt? No. And if you got these switched even, it wouldn't really hurt. But so there's 6. Reciprocals mean flip. The biggest challenge of this section might be remembering how to spell reciprocal. If you're bad at spelling, I do spelling as halves. So R-E-C-I-P-R-O-C-A-L. Reciprocal properties had to do with flipping stuff. Question about those? Second category is, I think, on quotient properties. What's quotient mean?
Answer to
Division. When have we been dividing among these words? Can you think of something divided by something, made something in our life? Because one of those words divided by another one of those words equals a third word among the sine, cosine, all those things.
Sine dividing cosine equals sine.
That is correct. If you divide sine by cosine, you do get tangent. I'll put stars next to a couple of these that I think are the best ones. This is, you want to learn them all. It's on a quiz, right? But in terms of homework and usage, the ones that I'm putting stars with are the most commonly used options that we're going to encounter. If sine dividing cosine makes tan, we might be able to reason out what cosine divided by sine would make.
Would be cotan.
It would be cotan. Because it's the same thing but upside down, synonym back to reciprocal again. Reciprocal of tan is cotan. All the ideas are a little bit intertwined. There's another way we could do tan. I'm going to base the logic off of this one. A sine on the top is equivalent to a cosecant on the bottom, because sine and cosecant are reciprocal friends. So instead of a sine on the top, I could do a cosecant on the bottom. Therefore, instead of a cosine on the bottom, I could do a secant on the top. So maybe you don't have to memorize that one as much as you can just build it. So if we know that this is a truth, what do you think would be a truth about cotan? If tan is secant dividing cosecant, what do you think cotan would be?
Cosecant dividing secant.
Cosecant dividing secant. Same thing, but upside down, because tan and cotan are flipped versions of each other. So there's 4 of those. The quiz tomorrow won't be numbered. When you do the test, at least, this is somewhat numbered. Like it says 1 to 6, do 6 reciprocal properties. So you know you're doing 6. Tomorrow you just have to know there's 6, because you're going to say reciprocal properties on a blank sheet and then list all the ones you know. So I would remind you there's going to be a total of 16, because 1 plus 6 plus 1 plus 4 plus 1 plus 3 is 16, but that's as much information as you'll get me is this is a 16-point quiz on a blank piece of paper. Questions so far? All of this stuff, sine, cosine, tangent, you probably remember is based on right triangles. Right triangles have been based on the Pythagorean theorem to some degree. So there's 3 things that use these words that kind of look like the Pythagorean theorem. One of which is sine squared plus cosine squared will always make 1. We've bumped into that fact every once in a while on some of our chart homeworks and things, and I'll drop that idea out there that you can shortcut some of them sometimes, but sine squared plus cosine squared always makes 1. 1 plus tan squared always makes secant squared. It's just the fact of Pythagorean theorem life. 1 plus cotan squared is equal to cosecant squared. I could explain those, but it would take probably more time than it's worth, especially based on what your interest level is probably as to why. If you care about why, and sometime we have 5 spare minutes, I'll do that. But I think for the rest of this duration of this period, you're probably better served by me doing some problems that look like homework problems. I would say these are all probably superstars. So learn them all, but if you're doing your homework, when you're doing your homework, I would lean more heavily toward, put a star on this one, I'd lean more heavily toward the 7 that I put stars next. So here's what you're going to be looking to do. My first bit of advice that will last you this entire chapter is, if you see anything that's not sine or cosine, see if you can make it sine or cosine. So that's why I'm saying these are superstar properties, because if you see cosecant, you can make it into sine stuff. If you see secant, you can make it into cosine stuff. If you see tan, you can make it sine and cosine stuff. If you see cotan, make it cosine and sine stuff. If you can turn everything into sines and cosines only, and kind of act like none of those other words ever existed, it'll make your life generally simpler. So my first bit of advice for the chapter, and I'll keep referencing back to it, is make as much stuff as you can, sines and cosines. My second bit of advice would be, also while you're doing that, though, keep your eyes open on squares. Anytime you see a bunch of squares in your questions, that's probably a giveaway that it's something with these Pythagorean properties that you want to use. So here's how we're using them and what we're trying to do with them. They're going to give you something with some words, some sine, cosine, cotan sort of words. And they're going to ask you to turn one thing into another. So why would you do this? Well, one would be to solve equations, which will be a thing we'll do over the chapter. Another will be to just take a big thing and make it smaller, which is something that is always encouraged in math. Take big things, make them littler if you can. So it's going to enable us to do those 2 things. But if you're asked to turn sine times cotan, I didn't write a multiplication sign, but when they're next to each other, they're multiplying. if we're trying to turn sine times cotan somehow into cosine, I would do this. I'd look at sine and think, I like sine. My teacher said I should make everything be sine and cosine, and that already is sine, so I'm happy. Multiplying. Cotan is not those words. He said I should try to make it those words, and I put stars on these notes. Cotan. Here's a choice. Cotan is cosine over sine. I'm going to try that one first. If that failed, maybe this property needs used once in a while. If that fails, maybe this property needs to be used once in a while. But this is telling you cotan could trade for this, or cotan could trade for this, or cotan could trade for this. I'd always try this one first. Because if I put here cosine over sine, if it helps you, this is invisibly on top of a 1. When fractional things are multiplying each other, now we're back to like old math concepts of elementary school, middle school. When you multiply fractions, what do you often try to do? Cancel. Can you cancel stuff here?
The sign.
The signs, absolutely. And if you cancel the signs, all you're left with is cosine. We were supposed to turn it into cosine, so we completed that process. All I would ask for you to do is try to supply enough information so I can think along with you. Okay? If you look in the back of the book, this chapter, you're going to be disappointed, because what it's going to say is answer is contained in problem. I think this is the message, something like it. Because you know this is what you're trying to make. The question is, how did you do it? So if you could write me a little bit of stuff to describe what you're doing. When cotan traded for this, we lifted that out of the quotient list. So if you could just write me a little note, like I'm using the quotient list. If it wasn't super obvious to my eye because we crossed these out that you canceled, you could write me a little note like I canceled, but it's sort of stupid to write me a note you canceled. I can see you canceled. I don't need that. But if you can give me a little bit of a like, what are you thinking kind of thing, that can help. Question about what happened there. I'm going to wander away, turn my camera on the series, I think. And I'll put it there in a minute. So I don't know if we captured all of that board, but there's some board capture. So here we go again. So this is a similar question. They're not all going to go like this. So don't just think, oh, I'm just going to multiply. Like there's going to be some variety. But this is similar to what we did. So I look and I see sine, and we're thinking sine's good, sine's bad. Sine's good. So I just leave that alone. Secant is good or bad? Bad. So I would check over there, which we can't see on the video anymore, but people that are watching the video should just write stuff down. We have some properties where secant equals something else. So what does secant equal? 1 over cosine. So I'll make that replacement, and then let's describe what we're doing to help out somebody who might have to grade your paper. Which list did we just lift that from? That's from the reciprocal list. Cotan. Is cotan good or cotan's bad? Bad. So let's trade cotan for something else. There's 3 possible things that we could trade cotan for. Pick the one with the star as the first attempt.
Cosine minus sine.
Cosine on top of sine. If this would become a dead end, then I'd go rethink that choice. Okay, because we had several roads we could have taken there, but I would always take the starred road first. If it makes you feel better, this can go on top of 1, but you don't have to do that. And then we'd again try to cancel. Can we cancel?
Yes.
Yes. So cancel, cancel, sines. Cancel, cancel, cosines. All that you're left with is 1. We wanted to make 1. So we're happy. Something about that. This one's clearly going to be different. There's no multiplying in this. This time there's stuff subtracting. So What property group do you think this is? Pythagorean. Why do you think that? We see squares. So we see squares, you want to think about the Pythagorean list. So you have to look at what you have and look at where you're going. So this has cosine squared. In the long run, that isn't there anymore. So that's got to be replaced. There was sine squared there. There's still sine squared there, so that doesn't need to be replaced. It's a little different, but maybe that difference will just happen naturally. Sine squared is our friend, we want it to remain. Cosine squared is not, we want to get rid of that. So here's the thing you're going to commonly have to do with the Pythagorean things, is deal with equations like this. If A plus B equals C, what is it that B would equal? C minus A. Or what would A equal? Working from that same kind of thing.
C minus B.
That would equal C minus B. We can manipulate those. You good with that? You good with that idea? The Pythagorean ones sometimes need to be manipulated. So sine squared plus cosine squared makes 1. If I wanted sine squared alone, what would it equal?
1 minus cosine.
1 minus cosine squared. Not looking at that, but looking back at the original. If I wanted cosine squared alone, what would it equal?
1 minus
1 minus sine squared. Agreed. So what I need to do with this one is the minus sine squared is fine. I'm going to need to do the Pythagorean properties to make a replacement for this. Cosine squared can go out, and in its place can come, what we just decided here is 1 minus sine squared. Question about that switch. There's going to be a lot of algebra in this homework. Okay, so our first little taste of algebra was a reminder of canceling. Like Algebra 1, Algebra 2, we did some canceling of stuff with Algebra World. What's going on here is you have essentially an algebra problem like if I said 1 minus y minus y, what would you make that be? 1 minus 2y. Because invisibly this has a 1 and this has a 1. What is that called in algebra life? It is combined like terms. And that's exactly what we're going to do now. This has a 1, just like this did. This has a 1, just like that did. If I combine these, I'm going to get 1 minus 2 sine squared. And what we wanted to make was 1 minus 2 sine squared. So we're out. Something about that. And I'm going to do some straight out of the homework. So I usually do for free number 7. Does anybody need a minute to get the rest of that one? You okay there? We're good. Number 7, right out of the book, if you want to follow along in the book, has a tan plus a cotan. And they want me to turn that into other things. So just start off with what they gave you first. It says tan plus cotan. Write that down and we'll turn that into other things. So tan, make a trade. Who can tan trade for? Sine over cosine. Since this has an A, that means everything's going to have an A. Every trig word has a thing called an argument. We've talked about that before, that after the trig word there's always a letter or number. So if this problem has A's, all the trig words are going to have A's. Cotan.
Cosine over sine.
Cosine over sine. Which list were we just grabbing that all from?
Quotient.
Now, you might be tempted to say cancel. No. Why is this not a cancel world? Because they're adding. Adding's not cancel time. Multiply is cancel time. Adding is time for something else. Adding fractions. Hopefully, for those of you that I had in 7th grade, I indoctrinated you enough as a 7th grader that this is still stuck in your memory forever. I start talking about adding fractions. What is it that you have to do? Common denominator. So we've got to make ourselves some kind of a common denominator. We've done algebra common denominators before. So let me do a problem like it that's just algebra. What would you pick for a common denominator of that? XY. And if you're going to change the bottom, you have to change the tops. So this bottom needs a Y. That means the top needs a Y. This bottom needs an X. So this top needs an X. We're doing that same thing, but not with X's and Y's, but with cosines and sines. What's new needed on the bottom? Sine. So if we're going to gain a sine on the bottom, we have to gain a sine on the top. That's going to be sine squared, because we're doing multiplications when we make these changes. So if the bottom's getting a new sine, the top gets a new sine, that's now sine squared. So what would this one be? Cosine squared. Then you check and see, is that what we're trying to make? And in the previous questions, the answer was usually yes. This time the answer is no, not yet. So then you try to come up with another idea. Does anything here catch your eye? Yeah. Sooner or later, this will start to really catch your eye fast. Anything catch anybody's eye here? It's the squares. Squares should eventually, you'll learn. Squares will catch your eye. What's squares code for? Pythagorean. So if we check our Pythagorean list, what's sine squared plus cosine squared making? 1. And then we check the paper. Is that what we're trying to make? You cross your fingers. Is it what I want to make? Oh please, oh please. Uh-oh, no it's not. I'm looking at sines and cosines right now on the board, but I'm looking at cosecants and secants in the book. So what do we have that can translate us from sines and cosines to secants and cosecants, or vice versa? Which, like a list, has translations from sine cosine to secant cosecant. Reciprocal does. Because if you just saw this, what was 1 over sine? Cosecant. If you just saw this, what's 1 over cosine? Secant. We didn't see one or the other, we see them both. So we're going to get them both. We're going to get a secant, and we're going to get a cosecant. And then again, we check the book. Is that what we wanted? And the answer this time is finally, yes. Okay. It's in the opposite order, but as we talked about over there, when we're multiplying, do we care about order? No. That one's maybe a little longer than average. The first couple were maybe a little shorter than average. You don't know until you're there. And again, the answer isn't like this. We knew we were going to get that before we even started. The answer is, how can you get from A to B? It's almost like a trig essay. You know, it's not like I say, hey, explain to me why this is true, and you're like, it's true because it's true. No, you need like to expound on how to bridge the gap. Something about 7. Okay, 1 to 6. I didn't do anything from 1 to 6 because 1 to 6 were like the first couple examples I did. Okay, 7 is a lot like 8, 9, and 10. So I'm not going to do anything from 8, 9, 10. But here's 11. Says tan. And then it has sine plus cotan cosine. So here's my second bit of advice. First bit of advice is always make sines and cosines if you can. My second bit of advice that'll last chapter long is if you see a familiar algebra structure, algebra, do it before you do trig. I'm sure by now in the course of the year of trig you've decided algebra is easier for you than trig. It's because algebra is easier than trig. That's why you take algebra, then you take trig. Right? So if you see a familiar algebra structure, do algebra before doing trig if the algebra structure looks familiar. This algebra structure should look familiar. If that algebra structure doesn't look familiar, it sure probably will when I go like this. Now, if I just replace these trig words with letters, what algebra experience have you had thousands of times with that this is sort of pushing you toward doing it? It's distributing. So what we're going to do is start off with this one with distributing. If you have a choice between algebra thoughts or trig thoughts, take algebra thoughts. So we go tan times sine plus tan times cotan times cosine. That's what that would look like if you distribute. Okay. I don't see any familiar algebra structures anymore. So then what's my other bit of first advice that I gave you a couple times already in the period? Make everything sine and cosine. So tan is sine over cosine. Sine is just sine. Put that over 1 if it makes you feel better. Tan is sine over cosine. Cotan is cosine over sine. Cosine is just cosine. Put it over 1 if it makes you feel better. You're never required to do that. That was some quotient properties that I just used. Bottom of this. So this would multiply. If we multiply that, it would make cosine. If you multiply these, sine squared. Multiplying that mess, you're not going to multiply everything in that mess. What are you going to do to make that less mess? Cancel. Cancel who? Cosine and sine. I don't know that I'd even write a descriptor for that. I mean, if I had to, I guess I'd say that or that I canceled. But it's sort of stupid to say that I canceled, I think, because I can pretty well see that I canceled. I don't know that that's really necessary for you to even say that. I think I'd follow that if I had to read your paper. Then look and see, is that what we want? And the answer is no, unfortunately. So we're looking at adding fractions. So if I hadn't said that, maybe you wouldn't notice that, but if I say adding fractions, I probably triggered you to a memory that I already triggered once today. That was mine. Just you're wondering who's in trouble for their kind of thinking. Common denominator. So with cosine and 1, your common denominator would be cosine. This is already good. If the bottom's already good, don't mess with the top. This, the bottom's growing, so the top has to grow. What would be the new top? Cosine squared. So we're in a world of common denominators now. Maybe something catches your eye. Pythagorean. Sine squared plus cosine squared makes 1. 1 over cosine? Secant. And that's, I'm sure, what we were trying to make. That would be a reciprocal property to finish it. something about that. It should be feeling a little easier once we've done a few. It's like, I think I kind of get what we're trying to do here. When you try to do this at home for the first time tonight, it will feel much harder again. Okay, it's different. I'm giving you a lot of tips. Hopefully you internalize enough of the tips that you can hear my voice or recognize the structures, but it's always harder on your own. It will be for a little bit. 11's like 12. Let me go to 13. Does anybody need a second for any of that? Good. Pacing is good today, I guess. Fast enough to get it done, but slow enough you can write it down. So 13, again I'll say algebra beats trig if you recognize an algebra structure. So do you recognize an algebra structure there? You saw something like this. Is it things you know how to do? And if so, what's it called? Formula. Yeah, anytime you have a two-term thing called a binomial multiplying another binomial, we just need the FOIL. The F stands for firsts, multiply the firsts, that's 1. O stands for the outsides, so multiply the outsides. I is the insides, so multiply the insides. L for last, so multiply the lasts, and now the signs will be squared. Is there any lingering algebra there that you feel like you can clean that up? Yeah, the minus sign and the plus sign, it's technically not called canceling, but I understand what you mean by that. You know, technically canceling is just supposed to be reserved for multiplying, but essentially what they're doing there is it's a combined like terms where they eliminate each other. A negative sign and a positive sign, when they're combined, they're just going to eliminate. So 1 minus sine squared. Then we check and see, is that what we want? And the answer is no, but we're close. I know that from experience. We have 1 minus sine squared. We're trying to somehow get to cosine squared. Does anybody have an observation?
Did you do something? Did you do 1 minus? Or
Which family do you feel like you'd be looking at? Pythagorean. Why do you feel that way? The squares. So I look at this. Sine squared plus cosine squared is 1 is the way it's memorized. But we did a bunch of algebra reshuffles. If you didn't do all the algebra reshuffles in your notes, maybe add them to your notes. Sine squared would be 1 minus cosine squared. We had that up a little bit ago. Cosine squared would be 1 minus sine squared. We had that up a little bit ago. We're presently looking at this one. We're looking at 1 minus sine squared, which on a reshuffle is cosine squared. That is Pythagorean. That is what we want, and we're done. Something about 13. I'll keep going 15 here. I think I'll have space. 13 is like 14. 15 is like 16, 17, and 18. And I think I'm going to run out of time before I get to 19. So maybe I end up doing 19 as part of tomorrow or something. Try to do as much as you can with these. This is a good chapter for if you don't understand how to do a problem, skip it, go to the next. Or if you don't understand a problem, maybe skip it till the next one doesn't look like it. Okay, so if you can't do 19, you probably can't do 20, 21, or 22 either because they all look the same. But maybe you can do 23 because 23 just looks different than the rest. 23 we're subtracting fractions. That maybe sparked a memory of subtracting fractions from like younger life, but just by saying subtracting fractions. But 17 we just want to square this thing out. So for 17, what we're looking at, which one was I doing? 15, sorry. 15, it's cosine, and they use a weird letter. If you don't like the weird letters, just put X's. It doesn't matter what letter it is. But I'm just putting the letters that they're putting. They're going Greek letters there. Cosine minus sine squared if it makes you feel better, squared just means there's two of them. So if you'd rather write the problem that way, write the problem that way. And we're going to just start by FOILing this out again. So these would make cosine squared. This would be negative cosine and sine in the same package. Then I call, yeah. Then this would be, again, negative cosine and sine in the same package. This, negative times negative, is going to make positive, and the sine is going to create sine squared. Another thing I should emphasize at least once today is there's not one right answer for these. So if you come in and you did one thing and you did a different thing and you did a different thing, you might all be right. And not everybody's answer is going to exactly match everybody's answer. That's not going to happen. For this one, observations, thoughts, anything that in any way catches your eye, be it algebra or be it trig, because they're both afoot. We could combine. There's -1 of this, there's -1 of that, so altogether there are -2 of those. So combining makes total sense to me. Another thing would make total sense to me. And if you want to combine stuff, you could combine, like, if you want to do two things at once, you could do two things at once. I won't use the word combine because I used to use that word in a different setting. Cosine squared here, adding sine squared later, what's cosine squared plus sine squared? It's 1. That's from the Pythagorean list. If you see those both at once, do them both at once. If you see them separately, then do them separately. That doesn't really matter. For 15, that is what we're trying to make, so we're good on 15. And then the bell is seconds away, so I can't do 19. But what we're trying to work today is from 1 to 24, as much as we can work.